All right, let's begin. Welcome to the stream. For all my Twitch viewers, I appreciate you checking in with us again and hanging out with us for this video. Another exciting episode of the Breadboard to Market series. For my YouTube viewers and subscribers, I really appreciate it. You sticking with us and checking out our videos and subscribing and all that. That's really cool. I really enjoy it. If you're new to the channel, new to the videos that we're doing, you like what you see, definitely like and subscribe and hit that bell notification to be informed of any new videos that drop. Let's just get absolutely crazy and see if we can hit a million subscribers on YouTube by the end of the year. Why not? Let's just reach for the stars. Let's go for broke. So in the last video, the last stream, we had built up the first pilot board, and we ran into a problem where we wouldn't program. So the way I am, I just went ahead and started trying to troubleshoot it, and I did a few things and couldn't get it to program. I tested on my office computer, and it still wouldn't program. So I'm not sure exactly what's going on with it. I have a suspicion, but I went ahead and pulled a couple of parts that could be an issue, replaced a couple parts. I pulled the ESP32 and put a new one on its place just in case it was the issue, because I've had that happen before. ESD damage, we'll take them out sometimes. I've had that happen, but that was not the case in this instance. New ESP32 did not solve the problem. And I was thinking to myself, well, wait a minute here. That's not really fair, because this whole video series is to really kind of go through, the journey, and troubleshooting failed pilot boards is part of the journey. So this video, we will work on troubleshooting. I have a couple of suspicions where the problem lies, but we're going to do some testing. But before we move on to that, I want to kind of switch over to my one camera, because a few things did kind of come in, and we're gonna for the future. So the heat sinks and the adhesive thermal tape, transfer tape, came in for them. So these are the heat sinks I had chosen to use. I went ahead and just kind of played around and got one of the thermal pads, pieces of tape stuck to the one heat sink. We're not going to apply it till we get a board that we know actually powers up and the stepper motor works. I don't want to waste these, but these are what we're going to use from now on this project. They're the perfect size, and they'll do fine for helping to pull heat away from that stepper driver. They came in. I've already received them in Odo and everything, so we're good to go. I don't know if I showed this, but this will be the stepper motor we'll be driving and testing. It's already got the gear for the timing belts that we're going to be printing and using for the endurance test, and basically we'll kill two birds with one stone with this guy. But yeah, so this will be the stepper motor. It's a little bit banged up, a little used, a little dusty, but it was one of the ones in my old 3D printer. I tried to salvage all the mechanical components, all the steppers and everything, extruded aluminum, to reuse in other projects. We'll probably have to pick up a few pieces of extruded aluminum, maybe some more brackets and stuff to build the test fixture, but we'll get to that when we get there. So that'll be the stepper motor we'll be using. And then I was digging through some of my other supplies, and I found this guy. So what we're going to do, so I picked up a couple of these off Amazon. They're panel mount ammeters, and they also do voltage, but we're more concerned with current. Should be more than accurate enough for, at least half an amp to full amps. So hopefully that'll work for us. So what we're going to do is, I'm not going to use a factory supplied panel. I'm going to design and 3D print panels for the front and the back, because what we're going to do is we're going to take our resistor, mount it up underneath, here's like the inside. It'll kind of mount up through here. Well, the panel meter over here, I don't know yet. That's kind of a design aesthetic. You know, power switch, because power switch, mainly because this guy needs to be driven by external power. So its internal electronics can operate. And we're also going to have like a 12 volt external power, because this I think will run up to 30 volts or something external power. We'll run everything off 12 volts. That way we can put a fan in here to help keep the resistor cool. So it's a little project box I picked up off of Amazon. Once I find the link from it, I'll just throw it in the resources. I actually kind of forgot I had this. I was just going through seeing what I had to build a test fixture out of, and this will be the perfect load test fixture. So yeah, we'll design and 3D print some panels for the front and the back for power input, fan, and then the panel meter and everything, and power switch and all that fancy jive. So off the front, we'll probably have our load, probably banana plugs. That's probably what I'll use for the load. I'll see. I'll just make sure I can find something that can handle the current appropriately. But that's the plan for this guy. So I'll set all this stuff aside, and maybe we'll work on that together. Who knows? Maybe down the road, because we'll definitely have some idle time, because that stuff's not done yet, and we're going to need it before these other tests. But the great thing is once it's done, it's be useful for future projects and other general workshop use. So it's not like a complete waste, and you guys will be able to be part of the journey. So I've got the board. Yes, I finally put it in a static bag. I still need to get ESD surface for myself, but we'll eventually get this. I'll get the ESD mats, get them tied in properly, and wrist straps for myself. We're going to do it proper. I'll have over here on my main workbench, and then the soldering workbench I'll set up the same way. So I've got the board. So after looking at the data sheet and the schematics for the ESP32, so let's go over to here. I'm going to go back. I'm going to go over to the main screen. So right here is the ESP32. So the ESP32 uses IO2 and IO0 for bootstrapping. According to the data sheet, IO2 needs to be low for the initial bootstrapping to go into bootloader mode. So I thought maybe there was a problem with the temp sense, because I've had it to where I kind of forget that when I'm doing design work and bench work. And if you've got something pulling this down, pulling IO2 down really, or pulling it up really strong, feel like a pull-up resistor or something for like an input or something, where the ESP32 won't go into bootloader mode. That has to be pulled low, as well as IO0. It'll have to be pulled low too for bootloader mode. Typically, with the auto program on the USB UART, the DTR, and the RTS signals control this transistor setup, and it handles your boot mode and your enable. But a lot of times this IO2 is overlooked and it's not controlled. So I pulled the temp sense chip off, thinking maybe that was just holding it a little too high, and it wasn't able to go into download mode. That wasn't causing it. So that's not the issue. So then I looked at the ESP thinking maybe there's an ESP32 issue, because I'm going to hook the board up, and we're going to pull up the COM ports, because we're going to connect. Okay, so I remember to grab my FTDI cable, so we're going to be using that as part of this testing. So board up, hook up the UART. Resources for this device. What in the world? So What in the world are you upset about? Okay, that I've never seen that message before. I've honestly never seen that. What in the world? Not enough resources. Full device, uninstall, yes. All right, that is something I've never seen. Let's see if COM19. Let's see. We're going to save this as ESP32, so I don't have to. I have honestly, I've never seen this particular problem before, where where it gives that error. Let me see if it's mad because of my webcam. Let me shut the webcam off. Okay, let's try that then. Wow, that is just 19. Oh, we can open. Okay, so here's what's interesting. So that scrolling text is the serial. So the ESP32 is actually sending data out on the TX line. And if we hit the boot enable, the device actually goes into download mode, which is very interesting. So the device is able to go into download mode. So let's disconnect that. Go into VS Code with the firmware. All right, let's put it to the COM port. And let's try flashing it. See, and that's another thing that the IDF has been really... Okay, so yeah, it's not going to connect to it. It's not going to try flashing it. So what we're going to need to do, what we're going to try to do is we're going to throw leads, fly wires basically, straight onto the RX and TX lines that are used for default FTDI programming. So we're going to hit 34 and 35 on the ESP32, and it's much easier to use your footprints, 34 and 35. So what I like to do is take a scratch piece of paper and just kind of, because this is going to be hard to see right now with my setup over at the soldering workstation. So I just take a piece of scrap paper and kind of just roughhouse the pin out. So it's 1, 2, 3, 4. So 4 from basically that bottom, from that pin number 38. 1, 2, 3. It's basically 4 and 5 over from reading from right to left. Those are the 2 pins we want to solder directly to. So I'm going to disconnect. I should probably turn off desktop audio so you don't have to keep hearing all that crap. But you know what? It's fine. It's fine. So what we're going to do is we're going to... Let's see if it gets mad at me and the webcam won't work. Oh, it's live. All right, here we go. Grab this. So I got 2 leads already I salvaged from another project. I try to save some of this stuff. It gets a little hectic sometimes. Oh, wait a minute. If I've got longer ones, I'll use them. Oh, I've got some longer ones. I mind sacrificing longer ones for the cause. And then we'll grab... Actually, these ones will be better because I don't use these much for anything male to female. Go. So we'll just make new ones, and these are longer, so they'll be a little bit better for us. All right, so I've got everything over there. I got my little scratch pad. And I see that the webcam has decided to say, hey, I'm not going to work. There we go. Now it's alive. I think me unhooking it and hooking it back up just kind of made it a little upset. So, we already know by remembrance that that first pin down there is ground, so we'll be able to tie the signal ground lead to. So, first things first, turn the iron on, let it warm up while we prepare our test leads. All right. So first things first is we're going to clip our little wires. So my primary fear is, since we're getting data out of the ESP32, it is shooting data out, that we're not getting data into it. So there's a good chance that, no, that was dumb. Trying to do this while talking. It's not easy. Trying to be gentle and not cut through. Don't worry, I'm going to trim those leads down a little bit. Those are a little long. Put these guys out of the way. They're still usable elsewhere. All right. Tin the leads. Ain't got to be perfect because of what we're going to be doing. Now, I'm going to go over to my workbench here and grab something. So these things are really cool. So I didn't design this. I found this off of the Bamboo online models. And it's really cool because this is what the person who came up with it designed it for, holding wires. Really great. It's not my design, so I can't sell it, or I would. But yeah, if you've got a 3D printer or you want to find the guy who, maybe I'll try linking them in the resources. I'll find them on the Bamboo site, the maker. These things are really great. So now we gotta just kind of trim these down. We only need a little nub. We don't need much to solder into the ESP32. Solder on my way, move that on my way, throw this stuff in the trash so it doesn't get caught up in here. Okay, so we know we're going to be those guys. And yes, I like my magnifying light to do this with. Clean the tip of the soldering iron off. We're going to go, so it's 4th and 5th. So 1, 2, 3, 5. And looks good. And I'm trying to do things on camera, but it's very difficult because I have to be able to see and do it without burning myself. So I'm sorry if you can't see everything. So I do apologize for that. In the long run, I'll get something better set up. It should be good. If anything, these should be temporary, so I'm not going to worry about them too much. Get the signal ground on here, so I have to. little bit of solder on the tip here. Boop, boop. There might not be enough here for it to grab hold of. Oh my goodness. Okay. Oh, I see what the problem is. Ugh. Locked on the actual head of the magnifying light. Loosened up on me. Come on. Quit being stubborn. It's always that last wire that's stubborn too. The last connection you've got to make. It's always that's stubborn that you're going to fight. And it's going to fight me. It's wanting to fight me the whole time. It's not want to go to plan, and that never does. Ha, now you're in. Now you don't have a choice. Alright, I'll turn the iron off for now. Alright, so I don't see any shorts, nothing that looks like it's going to be a showstopper. So, that off. Go back over to the workbench. Switch to the other camera. Lots of fun, huh? Oop, there we go. Now, hook our power back up. We're not going to hook the USB back up. Instead, we're going to use the FTDI interface. Let's see if it gets mad about that. Nope, nope. Got the wrong one. Oh, here we go. That is COM21. All right, so we're going to tie up our serial port. TXRX, I always get them backwards, and I don't really care. I will fix it later. I don't like the way you're not grabbing that pin, though. All right. Okay, so we're tied up to the FTDI. Let's take putty and let's open it up for COM21. All right, get putty. Load. All right, so we're going to turn it on. Okay, so there we go. Good, 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 good. That's good. So now we've got that. Hit the boot button. Okay, boot button, we're in programming. We're in download mode. All right, so that's a good sign. So that means we're getting serial data out. And that's straight to the ESP32. That's not even going through the UART bridge chip. So we have to turn this off. So that's COM21. Let's see if we can change the COM port here and actually program via the FTDI. Flash. Let's see if we do anything. Oh, I think it gets mad sometimes if you don't give it a second. Okay. So it's not even trying to program. So I figure we can try something very adventurous. Let's see if it complains, if it will let us have both of these serial ports connected at the same time. No, I have to turn the webcam off, unfortunately. Oh my gosh. Really, Windows? Really? Too many. Doesn't have enough resource. Come on, Windows. Come on. Seriously? Seriously? You're going to try to load me down all of this bloatware, but yet you're going to tell me I can't plug the maximum amount of USB devices that USB is supposed to support? Seriously? And this is a powered USB hub. It's not like the computer can't drive it. That is absolutely ridiculous. So we'll leave this set to COM21, and what we're going to do is we're going to open COM19. All right. And what we're going to do is we're going to the reset. Okay. So here's what's funny about it. All right. So this is the COM19, which is the should be the UART chip, the UART bridge chip. So we're going to go ahead and put it into boot mode. Perfect. And then we're going to tell the ESP30, let's minimize this so we can watch the terminal at the same time. All right. We're going to tell it to flash through COM21. So now if you notice over here, it's not even picking anything up. So COM19, okay. So it's like it's not, there's no TX data. Or R, in the case of the ESP30, it's not getting RX data. So what we're going to do is we're going to switch these around. We're going to switch this to COM19, which is the integrated COM port. We're going to open up PuTTY again. But we're going to open it up for 21. So we're going to reset the board. Okay. So now we're watching this. So we're also going to check to see if the if it goes into auto boot, auto load. So we're going to flash it. Okay. So So we've ruled out the Scilabs chip is putting it into bootloader mode, into download mode. That is not a problem. So basically, what that means is schematically, the boot and EN lines, boot mode and EN lines are being pulled properly, and it's resetting the chip and putting it into bootloader mode. So that is not the issue. It is going into bootloader mode. And the output, oh, why do I kick things on? I hate that. Sometimes my mouse likes to jerk. So what that's telling me is the chip is going into bootloader mode just fine. So it's not like the Scilabs chip isn't working. It's almost like either one, I have something tied in wrong, so we're not getting the RX data in from the UART chip. And that would be fine here because we're schematically tied up here. So 26 off of the I forget. 26, yep, right there, RX. Trace, it goes to a via to the bottom layer and back to the top. Right to the RX line. So according to the PCB artwork, it's there. So according to the PCB artwork, there's a good chance that A, it doesn't exist, or B, that maybe, A, that somehow like one of those vias is screwed up and the trace actually isn't completed. So we're going to grab a blank board because it's a lot easier to tag on or to connect to with a multimeter. And we're just going to see if that trace is actually connected. Granted, it could be just one flawed PCB, but typically if there's a problem, the whole batch will be shot. So I'm going to move the PCB out of the way. And so I'll be using the KiCad diagram for reference here. So it's the RX line. So it's TX or RX. So it's RX off of here. And TX off of there. So it's going to be, let me grab my handy dandy notepad. So we're going to go to 26 off of the... So, 1, 2, 3 over from that way. And then ESPRX is that guy and that guy. So, what we're going to do is back over to this guy. Handy dandy notepad. Is we're just going to check to make sure that we actually have resistance. So grab my, or no resistance. It should be pretty much a 0 ohm circuit. So we got to rule out PCB being a fault. We know the one serial data line is working. Is the other one fine? Just go in here because we're just checking for continuity. Turn that guy off. I don't need it in the way. So on the board, fifth one over, 1, 2, 3, 4, 5, and third one over. Okay. So we have continuity, at least on this board. So it's not an issue with that trace. Nothing's problematic there. So the good thing is we kind of got leads and we kind of know where things are off of our... So we put that board away. So, all right. So we know that's not the problem. Or at least we can assume that's not the problem because the other boards seem to be okay. To properly check for it, I should test the entire batch. But that's a headache. I should go through and test the entire batch. But generally, we should be okay. So I don't know if I can get that off of here, but we're not powered. That's the orange. Disconnect that guy. I don't know if I can get onto here. But what I can do is see if there's anything bringing that to ground. Let's get that out of... as I can tag here. 4.8 meg. Okay, so that's not a problem. Are they shorted out somehow? Wait a minute. 30 some ohms between the TX and the RX line. Huh. Okay. Now I'm going to double check the connection. That's cool. Got all that right. Let's make sure that my solder work isn't bridging the two. We're going to go to the microscope, which should be... All right. Oh, sometimes this thing's ridiculous to work with. Put you guys back. It's not really a short, but I mean, I could always pull that line, that wire, and we'll fix it real quick. Let's go and fix it. Oh, the webcam likes to be a little coy little duck. Oh, I know why it's mad. There we go. It's mad because I had to turn it off because of the whole serial port thing. I think what I might have to do is get another USB hub and kind of divide that out, even though it's kind of ridiculous because the standard, I don't know. So set that there. I'm gonna go ahead and slam things around, make lots of noise, annoy my wife. So again, this guy. Clean it up a little bit. Kind of repin it. Shorten it a little bit. Trying to get rid of that piece that's like huge at the end of it. Try to get a little bit cleaner connection. Boop. All right. See if I can make sure there's no... I want to rule this out to being anything that's causing resistance there. Turn this guy off. Okay. Looks good from that standpoint. Looking under the scope. All right. Yeah. All right. Okay, it should be isolated enough. All right. Okay. Let's now make sure there's no short between these guys. Okay, now we're in K ohms. Okay, that's looking more promising. Now let's see if we can get it to program. Sometimes too, that these guys, these ESP32s, I've had it to where they will be very, very particular and not want to program. There's the FTDI 21. All right, yeah. So let's see if I can get it to program. 21. Oh, we'll have to manually put in boot mode and push. Yep, there we go. It's upset. COM21. We're alive. COM21 FTDI. All right, VS Code. Access is denied. Do we have... Oh. Derp. That doesn't help. All right, let's try it again. All right. Okay, it's almost like something's still... Hold that down a little bit longer, make sure we're actually in download mode. Okay. Before I make them completely dumb, let's make sure that we do have our ports connected properly. Yep, yep. So it's not like that's the issue. Okay, yeah, again, our serial is still there. It just does not want to go into download mode for some reason. Or it doesn't want to send data. So it's like it's not. So there's a couple of things we can do here. And they are it's going to get more interesting. So what we can do to further diagnose this. So we can cut the FTDI chip out of the system completely. There could be a solder bridge under there, bridging that line. Maybe not direct shorting here, but it could be shorting somewhere else. Because I don't think we're hitting ground or anything with it. That's the orange one. I don't think we have a direct short to ground. No, it's open. So we have to think of our options of what would be the easiest and the best to do. One is we can pull the Scilabs chip and just pull it with hot air. We can just really quick grab the hot air. We can rework it. I can just pull it off and not even worry about it on this board, because if there's a solder bridge under there, it's going to be a pain to repair anyway, to rework. Because the main thing right now, I just want to make sure the ESP32 works. We can test a lot of the sub functionality. We just have to switch over and program via the FTDI. And just keep swapping back and forth, which is perfectly fine by me. I'm not opposed to that if that's what we need to do to at least start testing some of the stuff on this board. Or I can try to rework that chip, but we definitely need to figure out why. I'm not opposed to even building another board if that is the problem, paying more attention to how that goes down. Because if even pulling that chip off, the problem doesn't go away, we've got something else, we've got another problem elsewhere. So I think maybe that's what we'll do. We'll go ahead and use hot air. And no, I'm not going to scream at it and talk to it. I know what you're thinking. I don't have enough hot air to pull this little guy off. So we're going to use a little hot air rework gun. Sometimes I like to disconnect things, especially things like this that can burn and cause havoc if I'm not around to watch it. So I like to disconnect power and stuff. So, so that kind of stuff doesn't happen. Let's move the FTDI cable out of the way. I don't want to melt the poor little guy. Move these guys out of the way. Don't need to melt them. All right. Let's slowly bring up the heat. Got one of the smallest chips I have. Grab a pair of tweezers. Okay, start getting hot air. And the whole point is we're just going to be basically pulling this chip off with hot air. There we go. Now I've got like a dumb unit that doesn't know to keep running to cool itself off. It's not like the high quality ones. So I have to bring the temperature all the way down and just kind of let it cool itself off. So we got the side. Uh-oh. It kind of stuck to the workbench. So I got the Scilabs chip off. Unfortunately, there's no way to check for solder bridging under this poor little guy without an x-ray machine. And just the fact of pulling it off could have fixed the solder joints that were the problem. There is a lot of solder blob kind of right here on the ground pad, so it's a very good possibility something was shorting this little guy out. That guy I'm just going to trash, unfortunately. From a quick inspection, none of the there's nothing shorted out. So that's going to take the Scilabs chip completely out of the UART bridge. Okay, that guy's cool enough. Turn them off. I'll deal with moving everything and cleaning things up later. Grab my FPDI cable. I didn't want to melt it. Believe me, that's not pleasant. So, if this works, that will point us to the problem. Then we'll need to just double check our design, make sure that is not the issue, which I really don't think it is. I don't think it's miswired or anything. So, we're going to make sure we hit the enable, put it into download mode, and then we're going to try flashing it. Keeping my fingers crossed that this actually works. No. Oh, there it goes. It's writing. Boom. Okay. Okay. So what that tells me right there is something was wrong with that Scilabs chip. And either, like I said, it could have a solder bridge underneath of it, which can, when you get into these really fine footprints like that, like this little guy is, I mean, let's go back over to the webcam. Get you back over here. So, you know what? Better yet, let's. Why am I wasting my time on hooking that board? Let me just grab the new one. Grab a new board. It's a lot easier. So I'll have to dig up some of my supplies. I have stuff for hot air reworking, and I might try putting a new chip down. I don't think I'll have time for that today, and I have to dig up. I have to see what all I have, but I might be able to. I mean, I might be able to just. I mean, there might be the solder that's on there might be fine. I might have to do a whole lot to do a reflow one. I might be able to have enough time to try it, but I'm willing to take a chance. What the hell, right? So yeah, the microscope's gonna be better to illustrate what I'm trying to say here. Yeah, so that's the footprint for the Scilabs chip for the UART USB bridge. When you start getting these smaller pitch footprints like that, especially when they're under the chip, if you're trying to hand place this stuff, this is where you're going to have the most problems. Where a lot of times solder will kind of self-correct, and kind of flow properly. But when you start having pins packed close together with ground planes that close to it, there's always the chance that you're going to solder bridge the poor little guy. And when you solder bridge one of those little pins to ground or to its neighbor, you get the unexpected behavior. And I think that's what's going on here, is that we've got the unexpected behavior due to like a connection somewhere. So you run just a couple minutes over, it's fine. We're going to try pull this guy, put him away. Well, we'll just try using the existing solder that's there. Add a little bit of flux, and we're gonna try reflow, hot air blowing a new chip on. Now a lot of professionals, they'll pull off the old solder and put fresh solder down. That's gonna be an MSL part, of course. It's gonna be the crazy one. So the cool thing about MSL parts is if you have it out of the packaging for less than a couple of minutes, like just long enough to pull one out, and you reseal it real quick, you don't have to worry about logging your time or anything with it. So we're gonna try it. It's okay. These parts are a little bit pricey, but if we can get this chip to work, then we'll just pay the attention when we build up other boards. Because we're just trying to get through this validation phase. I've got 3 left, so I can always order a couple more. Hate to because of the prices that things are and the tariffs, but that's dev work. Those are expenses. Those are things you have to deal with in this industry. Successes and failures. And unfortunately, sometimes failures get costly. All right, so we got that sealed. I got my chip. Got put away, so that's fine. Got my scissors. I'm going to have to get another pair. So, flux. This stuff really isn't made for hot air rework, but it does work. I've tried it. So there should be enough solder left behind. Grab my tweezers. Move this out of the way. All right. That's proper orientation. Grab my hot air gun. We're going to try it. If this fails, it fails. That's fine. I know, trying to do things on camera, but also, taking consideration of my safety. Kind of get it hot. Try to get the solder. Hopefully that's on there. Give it a second to cool down before I... A little crooked. Cool off a little bit. And that might be good. Might be, might not be. On there. Let's drop the temp, let that cool off. And I'm just hoping for success. Because if this succeeds, then boom, we can not worry about the standard FTDI. Let it cool down a little bit more. And then we can just use the FTDI header for the testing and stuff. I'm really hoping this works. If not, like I said, we'll probably end up building another board. I know how long the first stream was, the first build stream, so I might just do that off camera on my own time. Because you've already seen that. And there's no reason to drag you guys through it again. But one of the things that we'll probably do the next stream is catch up on a few little pieces of paperwork. I might have to kind of break it up. I don't know yet. Might be able to get my workshop computer kind of set up properly to connect to the Odo database. Cool enough. That guy's good. So let's turn off that FTDI. That way, and we'll turn off the webcam so this guy does not complain. Power on. No smoke. Okay, so it sees COM22. All right. So far that's a positive. That means the USB is connected. Oh, I might. No, no. Oh, it wasn't ready. Oh, you know what? That might have done it. Maybe. Maybe. Oh, so hopeful. So hopeful. All right. Nope. All right. So it's failing. Let's see what. Load column 22. Does it? Wait a minute. So, okay. So data's coming out of the chip. Waiting for download. So we're in bootloader mode. Okay. All right. Let's see if we can flash it. No, sometimes ESP. Sometimes the IDF gets a little upset. Oh, weird. Sometimes you have to close it and open it back up. All right. So we're going to try something crazy here. So this guy isn't doing it. We are going to back to that FTDI. And we're going to program a different program on here. We're going to actually load the URFTDI because I've already kind of made this and it already works on the dev kit. So let's see if we can throw this. Let's first try that. Okay, COM22 still wants to be a little booger. So this is basically a terminal app that'll let us have a console, which means I can send data in and out. I want to roll out that. So we're going to switch back to the FTDI. I'm going to manually reset that. And we're going to flash it over the FTDI. Okay. Oh, maybe I need to get rid of this guy. Still not flashing. Okay. Okay. So, okay, so it still won't flash. Now I want to have to double check. Do I have, I mean, schematically, are we right here? TS RxD TXD. That is correct. ESP32. TX, RX. RX. Yes. We're correct there. $25 and $26. Are they correct here? 25 and 26. 26 is RX. Which is correct here. All right. Let's open. So over here. So that's a QFN 28. Yeah. QFN 28. So let's get the data sheet real quick. Pin definitions. 28 pin QFN. 25 would be 25 and 26 are the TX and RX. 25 is RX. Yep, 26 is TX. Okay. So we have the right footprint, the right chip. Everything there is correct. I'm going to have to look at the board to make sure. So we checked the board. Somehow the Scilabs chip, for some reason, this chip's not working. And I can't figure out why. We're getting data out, but we're not getting data in. So, all right. And we went by their recommended circuit for this and laying it out, their typical application. So that's self-powered. So this is reset 1K ohm. We've got that. Regen and VDD. Tied to 3.3, so that's not the problem. And that's all the criticals right there. Yeah, so design-wise, let's see what it says here. That's fine. Data carrier, okay, that's fine. Those are just the signals. We know they're working, the control signals, because it does go into auto program mode. Okay. Suspended. Okay, those are outputs, so they don't matter. No connect. All right. So couple minutes here. Let's just see. Grab the scope. Let's see how much it wants to complain now about having another USB device added. Little picoscope connected. Scope probes. There we go. It's got you. Plug you into A. Picoscopes are actually really nice. So what we're going to do is we're going to be monitoring, since we got these little leads pulled off. All right. Okay, grab you. So TX ESP RX is 34, so that's going to be the yellow lead. And so what we're going to do is try that out. Turn off that guy. So COM22. That's that port. Huh. Wait, nothing's coming out of that guy? What about the ESP? Okay, that should be. So we should be getting serial data. Let me. Oh, I wonder. So let's see if we can. So I should be getting something off of that. COM22. Oh. Now that it's programmed. Yeah, so that'd be the hello world we're supposed to get out of the USB serial port. So why am I not getting anything on the scope? Again, got a ground. Oh, there we go. Just happened so fast. So that is the ESP32, the data out. TX. So that should be RX. So that should be. What was that? So we should be getting a waveform. Trying to flash it. Yeah, we're not getting anything out of the Scilabs. Okay. Let's see here. Huh. Yeah, so we're not getting anything of the Scilabs chip for some reason. All right, so we're gonna try one more little thing, and I'm gonna try heating this guy back up just a little bit. See if maybe it just didn't flow right. Get a little bit extra flux around it. Maybe it still didn't flow right. Cool down. Then maybe it didn't flow all the way, didn't get enough reflow gunk under it. So we'll try. Let everything cool down a little bit, and then we're gonna hook back up and we're gonna try it again. And then I'll probably end this video and try one more time. Then we'll end the troubleshooting video for today. But if this does work, that's all it was. I'm hoping, keeping my fingers crossed, because these kind of problems are annoying. Some of the worst ones to deal with. Okay, so it shows like it came alive there. Still nothing want to come out of it. All right, so this guy is not wanting to work either. Not getting any data off of that guy, but let's make sure that we still have it off of the other line. All right. All right. Okay, yeah, I see the data. Okay. Yeah, it's just not on the immediate screen, so. Yep, so we're not getting data out of the Scilabs chip into the ESP32. we'll get data out of the ESP32, but it's not getting into. So we've rolled out quite a few things of what it could be, but this is getting curiouser and curiouser. Now, for the next troubleshooting segment, we'll try to put a different Scilabs chip. I think I've got a Scilabs chip. I don't want to run this too long. One thing, it is a work night. I do have to work tomorrow. And also, I don't want to drag you guys along too much for this ride. I got to dig up. I think I have the other version of this chip, which has the exact same pinout. It just has all the advanced features. I'll try dropping one on here and reflowing it with the hot air. And we'll see if we can get that chip to work. These Scilab chips may not be good. There may be an issue with them. And if there are, I'll have to look into it and maybe contact Scilabs about it. Silicon Labs. So for now, I appreciate you hanging out with us and going through this troubleshooting. So we have kind of isolated where the problem is, but we haven't exactly figured out what the problem is. So hopefully the next troubleshooting section we'll be able to figure out what the problem is. It's being very weird. It's an odd issue, and I hope it's not the Silicon Labs chips. If it is, like I said, I'll contact Silicon Labs, see what we can do about it. Maybe there's some addendums, some errata, some something they may know that I'm missing. But we'll see what we can do. I thank you for hanging out with me today, and I really appreciate it, you spending the time. And catch with you, let's see what's day, Wednesday, so Friday evening for the next stream, and hopefully we'll do some more troubleshooting together. Thanks, and take care.